when we know just about to take the moment you prepare what pen will be very hot, no? Okay, so okay, again, sir, like what do you mean by odd body? I don't know odd body. Okay, you do one thing. There's a major problem. Huh? Most of us, we don't know what do you mean by odd body. Okay, this is the, at least tea, a cup of tea, this one. So inside this, okay, this will be tea, no? And from here, like this, at least you can see that particular radiation will be coming like this. There's a hot tea, I'll write it. After some time, what we see, so like you just prepared very hot tea and keep it here. So initial temperature, let it be say like a 90 degrees Celsius. Temperature of surrounding 30 degrees Celsius. Also like a now winter, okay, let it be 15 degrees Celsius. After some time, what will happen to temperature of hot tea? Will be 20 degrees Celsius. Also like a 15 degrees Celsius. Surrounding air is also 15 degrees Celsius. Okay, now is it hot tea? No, it is a warm tea. Now what happened? Why the temperature of this particular tea has decreased? How it has decreased? Okay, everyone knows this. Okay, please do answer. Yeah, anybody? Some of you are very good in explaining things. Okay, come out. Yeah. Yes, anybody? Why do it will cool down? Sir, it will give out heat. Why you should give out heat? Sir, heat flows from higher body to low, higher temperature to lower temperature. Hot tea
Sir,
is at
air
night.
is acting as a conducting material to transfer heat, sir.
Okay, one explanation. Yeah. Okay, next anybody?
Sir, it will give out heat to come into thermal equilibrium.
Okay, zeroth law of thermodynamics. Huh? Okay, fine. Next. Yes, anybody? So I think every day now it's winter. No, it's a very good chapter. Exactly at the winter time it has come. What type of food we like to eat now? Hot? No, not very hot. Okay, something warm at least, not cold. No. And dining table, or some will sit on the ground. The hot will be there, rice or chapati, what all the roti, what happen, will put it, and it should be hot. No, now winter, then it'll be very tasty, especially the curries or sambar, what all we take. No, so it's be hot. Okay, so that what happen, we can enjoy the food, especially in the winter. Then if you just leave it, what happen, it will cool down. So make observation every day we are taking food. Every day we should have asked ourselves, okay, how it is cooling down. Are you getting observation? That's what I'm telling this one. Science is all about observation. Okay, no. Three answers, I got it. Next. Yes, anybody? No one wants to, or others are sleeping, winter, nice. Switch on mobile and okay, let the class run. Let me call individually names so that whether you are really present or not. Akil Kumar. Akil Kumar.
Yes, sir.
Okay, what is your view on this?
Sir, it will attain thermal equilibrium.
Okay, I know you know that one, no? Yeah, then. Abhiraj Mahajan.
Yes, sir.
Can you give reason?
First law of thermodynamics, I feel, sir.
I don't know first law of thermodynamics. You tell me.
As there is low temperature outside,
Hmm.
this heat will be transferred to low temperature.
Okay, there's a reason. Huh? Yeah.
Sir,
See, actually, uh,
sir, the particles in the hot tea are highly energetic, no, sir.
yeah.
So they come out.
Tea will come out. Huh?
No, sir. Steam.
So they evaporate, sir.
It will evaporate. Okay, then I would have
Become
The
of
discussed.
outer air will take the energy, sir.
No, I would have discussed this in calorimetry. Why I'm talking here separately? See, this is what science is not about just gathering information. From the beginning, I'm insisting you, please do think, please ask, please search for a reason. Don't just accept information, proceed. Not correct it is. Huh? You'll never become engineer. Some of you have taken foundation course. Some of you have studied this and worked out many numericals. Huh? And you have just come out like this, gathered information and came out, not analyzed. Huh? Come out of this method. Maybe you may get you'll get a rank in competitive exam, but not knowledge. Huh? This sort of acquiring knowledge will not help you anywhere. I'm making things clear. IITs all what happened, you may think they're very big place, but you look at it in terms of science and technology, hardly they find any place here. Hmm? Okay, let's get into this one. So actually what happens is like, let's go back to the temperature definition. All are interrelated. So if you go back to the definition of temperature, what is a modern definition of temperature like? The degree, the degree of measure of the randomness of the atoms, vibrating atoms in a body. If the atoms vibrate more rigorously, it is said to be higher temperature. If the atoms vibrate with less rigorously, then it is said to be at low temperature. So as you increase the temperature of body, the atom starts vibrating more rigorously. So the degree of random vibration of atoms is nothing but the temperature. So now what is this particular thing? As the atom vibrates, it will have electrons. The nucleus will have a charge. In fact, the charge is vibrating. The charge is accelerating. And according to Maxwell's law, accelerating charge particle should give out electromagnetic wave. This is a basic idea. The reason why, what happened, when these molecules of the hot tea, of the tea, what will happen, they'll start vibrating. And any particle, any charge particle, if it accelerates, should give out electromagnetic wave. So therefore, what happens, it starts giving out energy in the form of electromagnetic wave. There's a one reason. We'll discuss this EM waves in detail in the second year syllabus. There's a basic idea we must have. Okay, fine. So once you pour this hot tea also starts giving out radiation. The saucer, the ceramic, it will also become hot. No, I think I don't drink tea, so I don't have much idea about these things. So you most of you might have take hot tea or coffee, that one. So any hot, what will happen if you put it? No, suppose if it is a steel one, even the steel will acquire, no, due to conduction. The steel atoms also start vibrating. The charge particle there will accelerate. Due to vibration means they'll get accelerated. The steel also start vibrating. Later we'll discuss that detail. So now the atoms, the particles here, the charged particles inside the T, what will happen? They'll vibrate. Because of that, they'll get accelerated. And because of acceleration, any accelerating charge particle should give out radiation. There's a one specific reason what we can give. Why that electromagnetic radiation? Okay, fine. This is okay. Like this, what happen? The hot tea, what happen? It will lose out energy in the form of radiation, and it loses energy. If a body loses energy, temperature should decrease. So like that, it will from hot tea will become warm tea. Okay, this is called like a emission. What we say. Okay, but what we notice is like Okay, let's go for, okay, the same thing. Okay, I'll bring one very important difference. So these are odd T, and I do have a cool drink bottle. Hope, I think cool drink bottle. Yeah, this will be. Okay, anything, let it be. Okay, let this be Maza. Okay, now good advertisements are coming in TV. Let me take this cool drink, Maza, that one. Okay, this is, so what is the temperature of this? Okay, it will be cool. Okay, 90 degrees or T. The temperature of surroundings, let it be 20 degrees Celsius or 25, will take it. This one, this is a air. Then this will be say like at 5 degrees Celsius. What actually happens? There's an initial. Finally, what will happen? This will become just T only. I'll write it. Temperature of this will become 25 degrees Celsius. Temperature of this also will become 25 degrees Celsius. So what actually happens? So this is this object, this odd T, shall I say, cooling down, and whatever the cool drink, it is warming up. No, it will gain heat. So finally, what happens? This will become warm. Will I agree? This there's a very general thing what you might have come across. I just took example. You can try this if you're interested. Take thermometer, around 90 rupees. What happens? You'll get thermometer, purchase it, and you can do experiment. Okay, let's come for the discussion. Okay, what actually happens here? It will give out, it will cool down, and it will warm up. Okay, now let's come for this one. What will happen? Well, radiation will stop here. So what will happen to cool drink? It will absorb it, it gains heat, and the temperature of that will increase. So finally, what happens when the temperature of the tea and the cool drink will become that of the surroundings air? No longer heat exchange will occur. Will you agree? The answer is no. So what is telling is like all bodies radiate at all temperature. So initially, how the body will cool down? It will have, so emission I'll show by red color. I'm showing this one. It will absorb. Absorption is this one. So here what will happen? Even this maza also what will happen? Bottle will radiate. And it will absorb more heat. You see red colors, that one. Finally, what will happen? How much it will emit, that much what will happen? It will absorb. So I think now the emission and absorption both are there. Try to notice that red color and the blue color one. Okay, initially what will happen? You count it 1, 2, 3, 4, 5, 6, 7. I should show more lines. Arrows direction also I'm showing. I'll remove few. Yeah. Yeah. So initially what happened? How do it will cool down? It will have more emission. So it will emit more energy than what it absorbs. So here first what happened? Emission, I'll say emissive power. So it emits more radiation, it emits more energy than than it absorbs. So this hot what happened? It is also emitting and also absorbing energy. But the rate of emission will be greater than the rate of absorption. That's why it is net, it will be losing. So the temperature of the hot tea will decrease. What about for the cool drink? Its rate of absorption will be more than rate of emission. So what this cool drink is doing? It is also emitting and also absorbing. But since the energy, the rate at which it is absorbing energy is greater than the emission, that's why it is warming up. So what is hot tea? It is cooling down. And this is warming up. Okay, now come for this one. Thermal equilibrium is achieved. Now at thermal equilibrium, no, at thermal equilibrium. So what actually happens, like the rate of emission is equal to rate of absorption. At what rate energy is emitted, at the same rate energy is absorbed. So therefore the net heat gained or lost will be zero. So therefore the temperature of tea will remain constant. The same thing happens for here also. How much of power it emits, that much of power it will absorb. And the rate of emission equal to rate of absorption. So therefore the net temperature, therefore the temperature of the cool drink will not change. So like this, it will be in thermal equilibrium. Okay, fine. Are you able to understand now? This is like, so therefore all bodies radiate at all temperature. Even this cool drink, what will happen? If it is cool, what happen? It will emit and also it will be absorbing. So when a body will cool down, if the rate of emission is greater than rate of absorption, the body will cool down. When a body will warm up, when rate of absorption is greater than emission. So like that, it will absorb more energy than emission. So like this, what this particular cool drink what happen will warm up. At thermal equilibrium, how much of energy emitted, that much will be absorbed. Cool drink also, how much of energy emitted, that much will be absorbed. Okay, next question comes, sir, what is radiation? Both absorption and emission are called as radiation. Both absorption, emission of heat in the form of electromagnetic wave. Is called as, there's a basic idea. Heat in the form of electromagnetic wave is called as radiation. The flow of energy in the form of electromagnetic wave from a body to surrounding or from surrounding to body is called as radiation. What is radiation phenomena? Not only emission, both absorption as well as emission are called as the radiation. In general, what when we think radiation means only emission? No, both absorption phenomena and emission phenomena in the form of electromagnetic wave, the heat in the form of electron is called as radiation. Okay, now radiation requires any medium? No, radiation doesn't require any medium to flow. Okay, it doesn't medium. Next again, all bodies radiate at all temperature. All bodies radiate all temperature. So means now, sir, is it cold drink radiating? As even you can do one thing, ice blocks at -10, you keep it here. So ice blocks are emitting, yes, they're emitting. They're emitting energy and also absorbing energy. But the rate of absorption will be more than rate of emission. So therefore temperature of ice will increase. Then it starts melting. This is what the phenomenon. So like this, what will happen? The radiation, how a body will cool down, how a body will warm up. At equilibrium, what will happen is what we are analyzing here. So both emission and absorption is called as radiation. Okay, now got slowly idea. So at any temperature, what will happen? The atom should vibrate. The molecules, or you can say charged particles in that substance should vibrate. Due to vibration, there'll be electromagnetic wave, and that electromagnetic wave will propagate, and that is what we call as a heat. So here, the heat in the form of electromagnetic wave is called as a radiation. There's a basic idea. Okay, now we'll come for the oil leak lamps. Okay, this I think all of you very familiar with these things. Okay, we'll put some oil. No, how that light is coming? We have to ask ourselves so many questions here. There's a oil. Here that cotton thread will be there, no? Shall I call this a leak? This is the thing. Next, one more thing what we are familiar is the candle. I'm just asking you to really think and analyze, because so many examples what you have already come across. Okay, now tell me like what makes it to emit light? Because here, what makes this particular oil? So here, what happened? First, we have to lit it, no? So once what happened when you take the matchbox and lit it? So due to that high temperature, the oil molecules which are near to air, because that high temperature point, they start vibrating. And they start vibrating, then what happens? They'll give electromagnetic radiation, and that electromagnetic radiation will be there in the visible spectrum. That's why we get light. The same thing happens with the wax here. I think there's a wax candle. Am I right? I think so many from past so many years, you wanted to be a science in high school. You came across the science. You should have asked yourself, looked at candle, looked at this Lea lamp, how it happens. Never bother, no? What you were bothered about more, what like? How many questions let me memorize? How many marks I'm getting in weekend? Because it's all about, I think, very in the school itself, what happened, than acquiring knowledge, what happened. I should get a rank. I should be the topper. Okay, this was the main priority, no? The knowledge was put in dustbin. Okay, no, come for here. What actually happens here? Like when you lit it, what will happen? Because of high temperature, the molecules here, what will happen? They'll start melting. The wax will melt. And here, what happen? The particles will start vibrating. Due to that, what happen? Electromagnetic radiation, what happen? Will come. This part will be solid. Here it will be melted one. So like that accelerating particle again will give out electromagnetic in visible spectrum. That's why we're able to get the light. I think, do you think that radiation is what modern science only brought this? Long back, people know how to get visible light by putting oil lick this one, or by candle. If you go for Western civilization from past 2000 years, they were from 2000 years they were able to get this wax candle. If you come for Indus Valley civilization, no, billions of years the people know how to produce visible spectrum, how to produce light. Okay, these are the things are there. Okay, this is about the basic introduction about the radiation. So here, the energy will be in the form of visible spectrum. We are able to get this one. All bodies radiate at all temperature. There's the one basic idea, whether cool body, hot body, or warm body, irrespective of that. I set -10. Will it radiate? Yes. Now, you are sitting in your room. Is it walls radiating? Yes. Your body is radiating. Yes, your body is also at temperature. The ice cubes in your refrigerator, are they radiating? Yes. All bodies radiate at all temperatures. Finish all. Everything is radiation here. All bodies are radiating. The plant, road, your walls, table, pen, notebook, mobile screen, the mobile parts. Okay, that one. Chocolate, ice cream, everything is radiation. Don't think radiation is candle, everything in that one. All bodies, what you see surrounding you, are they radiating. Please do imagine. Try to imagine the radiation coming from them are falling on you. Your body is also radiating. The imagination is needed. Okay, fine. Okay, let's get into. Okay, now how to express this radiation phenomenon. Okay, now we came to know emission, absorption, something. So how to bring any formulas? So we need some sort of a like a method, no? Some formulas are needed to really explain this quantity. Okay, the radiation, will it propagate? Yes, it will propagate. So let me read some. So I already explained some basic thing. So what happened is radiation, in fact, radiation, will it be at rest or it propagate? The radiation will propagate with the speed of light. Okay, fine. This is the thing. Now, this particular radiation, will it obey any laws? It is similar to like a optics, visible spectrum. The thermal radiation, what happen, will get reflected, will get transmitted, will undergo the refraction, interference, diffraction, polarization, all the things. So let me put some points. Radiation, thermal radiation. Okay, again, radiation, you may go for this one. Thermal radiation follows or obeys, better, you write. Obeys the law of reflection, refraction, interference, diffraction, polarization, all the things. Okay, then this thermal radiation exerts pressure on the surface on which it is incident. It will exert also force. Okay, this one. So these are the similar to like in optics, what we said, light, no? The radiation, what can be invisible, infrared, anything it can be. Thermal radiation. So for what this oil leak and wax candle, it will give thermal radiation in the visible spectrum. That's why we are able to see that radiation. Okay, this is a background about this one. So next, what happened? We have to how to express this radiation, amount of radiation. Okay, this so some sort of I need this one. No? So therefore, so we'll go for emissive power first. Emissive power, we don't have any symbol in the book. I'll write it like this. Huh? Emissive power. So it is the total energy radiated per unit area, per unit time, per unit solid angle. Total energy radiated per unit time, per unit area, per unit solid angle. So this will be the symbol. We'll write like this. Huh? Emissive power. So this will be the total energy. Energy, you can write it as U, delta A, delta T, unit solid angle, delta omega. Okay, this will be what you can write, joule per meter square per second, or this will become watt per meter square. Like this, we define emissive power. Next, absorptive power. It is absorptive power. We define like this. In books, no symbols. I'm just introducing here that one. It's like a ratio. It's a ratio of. It is a ratio of amount of radiation absorbed in a given time interval to the total amount of radiation incident upon it in same time interval. So this is absorptive power. So what should we write here? Absorbed energy, absorbed power, or energy, whatever you want, absorbed energy to the incident energy. It's a ratio. It will not have any units. Am I right? Like this, we can define the absorptive power. Okay, so somehow what happened, I just brought a formula to express that radiation phenomena. Because in radiation, what happens? Both there'll be emission as well as absorption. Am I right? So how to differentiate between emission and absorption? Okay, like this is what happened. I introduced a basic definition. Radiated. Yeah. Okay, now what happened, with the help of this, I can classify now the type of material. So I'm interested here, like an ordinary body and the perfect black body. Let's discuss that one. Okay, of all this, next
Sir.
one more. Oh, yeah.
Sir.
Ah.
Sir, in emissive power, sir, in the formula.
Ah.
Sir, what is delta? What is it, sir? Something.
Solid angle, unit solid angle. Of course, we don't discuss much, no. So as it is unit solid angle, steradian, we not to bother that.
Okay, sir.
Some books they avoid it totally. Need not to mention. Okay, if you want, you can leave it. Energy rated per unit area per unit time. Per unit solid angle also we should take. Since the most of the numericals, what we do know, the solid angle idea will not be there. That's why in our books they avoid it. In SCRMA, he has mentioned. That's why I just picked up. That's why the units I didn't write. Steradian not needed to write. In SCRMA mentioned. That's why you may get confused. That's why I brought it. If you want, I'll remove it. Okay, no, so this is, and so we have a law, Provost theory of heat exchange. So what is that? All bodies radiate at all temperature. I mentioned it. This is something very, very important. All bodies radiate at all temperature. Everything only at absolute zero, what happens? There won't be radiation. Minus 40 degrees Celsius, highs at minus 40 degrees Celsius, as it will emit radiation. Okay, this is something very, very fundamental. All bodies radiate at all temperature. This is going to help us a lot. In all our numericals revolve around this idea only. Okay, these are the some basic things what I brought it. To express that radiation phenomena, I just introduced these quantities. Okay, now I'm more interested to learn this radiation phenomena, especially